Okay, we're now on to convex diverging mirrors. So if it's a mirror and it's convex, then the rays diverge. And what does that mean? It means, if we look at our diagram here, let's just do all our work on this one diagram. It means that if I have a ray, here's my object, and first of all, notice that this time we do for convex mirrors, we draw the focus and the center on the other side of the mirror. So we're going to be dealing with virtual images here. So if I have a ray and I follow my rules that I learned for concave mirrors, and it goes parallel to the axis, now clearly this ray is not going to bounce back in this general direction, is it? Because of the angle, the law of reflection, the normal at this point is something like, look sideways, something like this. Maybe not like that. Let's try that again. So more like this. And so your reflected ray goes generally in this direction. And that's why it's called a diverging, because the rays are going to diverge. So the ray goes that way. And what we have to do for this one is we have to extrapolate that one, since the rule is that it goes parallel, it goes through the focus. So we extrapolate it back through the focus, right there. Okay, so there's rule number one. Rule number two says if it goes through the focus, then it's going to go parallel. Now, we're going to skip that rule for now. I'll do it in a minute to show you how it works. But for convex mirrors, it's easier to use, it's usually easier to use the center rule. So what you're going to do, and the best thing to do here is get a ruler, put your ruler from here to the center, and then just draw a straight line, because what's going to happen is, as I draw a straight line there, I'm just going to eyeball it as best I can. It's going to hit at a 90-degree angle right there. So wherever that hits at a 90-degree angle, it just reflects on itself. So it just goes straight. In other words, it doesn't straight through the center. There we go. And I should have actually done that as a dotted line. Let's do that again, because it's on the other side of the mirror. So this should be dotted. And wherever those two lines meet, there they are. Those two dotted lines meet. There is my image. So for this convex diverging mirror, this image, as you can see, it's upright or erect. It is smaller than the original. And since it's on the other side, it's a virtual image. Okay. Now, if you do, this is how the focus rule, the second rule, works kind of the same way as the center rule. What you do is you get a ruler and you extend it from here, from the image to the focal point, and then you draw your line. But when it hits the mirror, then at that point, then it goes parallel. So it's the same rule. It's really going through, I mean, I extrapolate that, that's going through the focus. But when it hits the mirror, then it's going to go parallel. Again, as you can see, they intersect at that point. But that rule for convex mirrors is sometimes can be a little confusing. So for convex mirrors, I usually try and go with the first rule, the parallel, and the center rule. Okay, so that's we're not going to go through all the permutations for convex mirrors, but here in your notes you can see some good diagrams for that, and that's it for convex mirrors. Yeah, convex mirrors, and we're going to do a separate lesson now for this one because this again is fairly long and intense. The formulas for all these mirrors. So stay tuned for lesson number 4 on 26.